Hello and welcome to a brief tutorial on how to put together a tiled piece that is using puzzle joints for a CNC router. Um, I just want to go back to the very beginning and start from um, the idea and work our way all the way to a file that you can actually, or a set of files that you can actually then export to a CAD/CAM software, and then finally to a CNC router. So as a recap and review, let's start at the very beginning. Um, Here you see the initial design, and what I've done is I've essentially created the design and then tiled it at these four different locations here. Depending on your design, you could tile it off of different vertices or random points along the shape like this, but for the most part, this is just kind of a very basic design, and most of you guys have already seen this. So moving on, you then want to integrate a series of tabs or locking puzzle type pieces, which will prevent this piece to come apart. Um, my final design will have the star actually cut out of this tile, and um, these tabs are what are going to actually hold, let's undo that, hold the four different puzzle pieces together. A few things to mention and to note is that all curves and tight corners need to be greater than eighth of an inch um, diameter, or a curve itself or arc has to also be greater than 16th of an inch diameter in order for the router to actually be able to cut your exact profile and shape that you want. Um, Let me see here. Okay, so basically what I've done is I've transitioned from this shape to actually dividing the design into four different tiles. There's a number of ways of doing this. You can either copy certain parts of the shape, or you can copy the whole item four times and delete three out of the four quadrants that you don't need, and then you do that four times, and then you can assemble all four tile pieces. And then in this quadrant here, what I ended up doing was I ended up arranging it in a way in which the pieces will actually fit a little bit tighter, and reducing the actual waste of the material. Um, what I also performed was my offsets. So if I zoom in really closely here, you can see that there is an actual offset of the entire profile. Um, this entire profile is actually one closed curve. That's something else that you need to be sure that you have. In Rhino, you can do that by selecting a series of curves, and up here in the dialog box typing in join, and then that would actually join all those curves together. Um, but going back to this, essentially what I've done is I've offset my closed curve 0.005 or 5 thousandths of an inch. That will actually give me a decent tolerance where I'll have enough room to actually manually put the pieces together without creating too much play and slop in the pieces. So then finally this brings us to setting up the file for the CNC router. Okay, so I've essentially transferred this drawing over to here, and then what you see is you see these things in red, which are going to be my pattern or my parts of the puzzle, and then you also see these orange, as I highlight they turn yellow, but these orange circles, these are going to be my hold downs, where I'm going to actually create a drill pattern where I'm going to then allow the router to drill these holes, and then I'm going to go back in between files and screw down my piece of plywood down to the table onto the sacrificial piece of wood. What this does is it actually holds the material down while the router is passing over it, ensuring that we have a very flat and even surface. So let me just turn off everything else except for the two important files that I'm going to really want. So I'm going to turn that off, turn all that off, and let's see here. Okay. All right. So basically, I'm left with this. I'm essentially left with all the holes, which are highlighted here. You can see these. Okay. Now, all these circles are 1/8 of an inch. Um, that is because obviously the router bit is 1/8 of an inch, so it's going to drill 1/8 of inch holes. Um, Also keep in mind, I'm putting not only the holes and the pattern as close as I can for the most part to the XYZ0. You want to make sure that your file is in fact closest as close as you can to the XYZ0. Um, let's see what else. Oh, parts need to be at minimum 1/2 inch apart. That includes both the pattern itself and the holes. Um, so the distance from holes to the pattern or the distance from part to another part need to be at least a 1/2 inch. Probably not necessary to be any less than that, but definitely a 1/2 inch. Um, also, let's see what else. Okay, so when it comes to actually like saving these things, a few ways of doing this. You can either create two separate files where you have one file that's just the holes and the other file that's just the pattern, or what you can do is you can actually, in Rhino, you can select what it is that you want to be exported, and you can go File, Export Selected, and it'll actually give you an option to export it. And then here I can come in and I can export it as a DXF, which is what we're going to need to export it as. I can do that for both the pattern and then the holes, and then that'll allow me to have two files that I can then send to my CAD CAM software and then finally upload that to the CNC router. So hopefully this was helpful. Hopefully this clarified some questions that you may have had for this project. Feel free to email me or stop by if you have any other questions. Thanks.